Good afternoon, everyone. Welcome to this edition of the NITheCS Colloquium. I think this is a very special colloquium because this is the week in which we officially launch NITheCS, on Wednesday. You're almost and welcome to join us there. And Bruce's talk is sort of the prelude to the festivities. So it's my pleasure to introduce to you Bruce, in case you don't know him already. Bruce studied at UCT, then completed his PhD in Oxford, spent some time as a postdoc in Italy and Oxford. I'm not sure in which order. Came back to South Africa, cosmologist, and became a machine learning guy. So something must have gone wrong along the path. So Bruce, we are really very happy that you give us a nice talk about insight in the future, maybe. Let's see what the answer is to your question.
Awesome. Thank you, Francesco. It's great to be back. Right. Is the audio okay? Not too loud? Cool. Okay. Technology. AI is going to take over the world, but can it move the slide forward? Does not seem to be working slowly. Did it switch off? Anyway. Maybe, let's see. Well, I can, no, nothing is working. Oh, well, I'll do it manually. It's okay. It's cool. I'll just, I think I can point this way. And so let me start by asking why give this talk at this time? And really there's two main reasons. The first is this has been an incredible year for AI progress. And I think it's such an important topic that I really think we need to engage as much as possible with the implications of AI. And the second is that I gave a talk at WITS, and afterwards there was a reception, and I was buttonholed by someone from the education department, and they were like, I just need you to know that AI doesn't think, it's not intelligent, it doesn't reason, it doesn't understand. And we had this rather tense conversation where they were arguing, no, it's just predicting the next word, so it's not intelligent, etc. And I was very frustrated because I asked them, oh, well, would you consider yourself an expert on AI? And they were like, no, I just follow some neuroscientists and they said it doesn't think. And then I said, well, have you tried it? Wouldn't you? I find the reasoning capability pretty impressive. And they said, well, I've never tried it. I've never tried AI. So anyway, this is partly a response to try to reason through some of these issues about, how good is AI? Oh dear. Okay. So, some questions I think come up, let's imagine that it really is true that AI just predicts the next word, the next best word. Does that necessarily mean it can't reason or isn't thinking? Like maybe the criticism is right. It is just picking the next best word. Does that mean it can't be intelligent or can't reason? And sort of similarly, like, are humans doing something more than just predicting the next best word? I could have said the next best camel, but that would have been a bad choice, right? And in fact, you could say in human brains, electrons just move around following the best path, least action path according to the laws of physics. That means that human minds can't reason or so. I think there's some interesting philosophical questions. And then, of course, we have a question that I think comes up. So this is the latest trackingai.org. They track all the models against a few IQ benchmarks. And this is the Norway Mensa quiz. And you can see that, let me try this. Sorry, this is an IQ test. Can I get it? Okay, you can see down here that you have three different models, GPT-5 and Gemini, that have an IQ of nominally of 135, whatever that means, So you can ask the question, well, what happens when the AIs have an IQ above 150? Are we still going to, is this person still going to be arguing, oh, they're not really thinking, right? And what about 160, 170? At a certain point, it just doesn't become that plausible that the systems are not thinking. So, of course, this issue of AGI, the broader question of the topic, is full of hot air. And hopefully we can reduce the amount of hot air a little bit and get down to a bit of the nitty gritty. Although some people who know me would say that hot air is one of my specialities. Anyway, let's start off by defining AGI. It's a very fuzzy term, right? But here's one definition that sort of at least captures a lot of the important ideas. AGI is an AI that can transfer learning across tasks, is able to set and pursue goals in unfamiliar situations, and improve continually, much like a human would. So that's, I think, is a reasonable kind of list of things we'd like. So my own view and bias is that I think in many ways we really have already achieved AGI in some very specific ways, but some really real ways. And I'll try and convince you, you may or may not be convinced of that. My own bias of I have to admit, is that, I switched, as Francesco mentioned, in 2012, I pivoted all of my research into AI because I became convinced that this was inevitable. So of course I have sort of I've given 13 years of my life to this. So if it turns out to be wrong, there's a little bit of entrenched loss there. But at the same time, the projections I made back in 2012 of when we would get to places, we have hit them always faster than I expected. So, although I may be invested, I'm pretty impressed as we go along. Impressed, scared, both of those. Yeah. And on this AGI question, I think quite a good analogy is, you're driving from Pemba in northern Mozambique down to Cape Town, and then you get to Stellenbosch. Like, have you got to Cape Town yet? Well, not really, but on the scale of this map, yeah, sort of. You're on the outskirts of Cape Town, and then when do you say we have arrived? Reasonable people can disagree, right? And say, no, you really need to get into the foreshore. What about when you hit the southern suburbs? So I think this is sort of where we are. We're at this point where reasonable people can have different opinions about whether we've got there. And, this is sort of my journey from 2012 to 2025. I think we've really come a long way. I think I didn't want to do that. So I think one of the dangers of fixating on AGI, are computers able to do what humans can do? I think there's a danger of falling into this trap of that we humans always do, of saying we're special, right? Okay, it used to be that we believed that we were the center of the universe. Then we had to give that up. Then evolution came along and we gave up the idea that we're fundamentally different from animals, but we still think of ourselves as the pinnacle of intelligence in the universe. And so when AI comes along, we ask, is AI as good as us? And I think that's potentially very dangerous, because we're not looking at the flip side question is, what are things that we're not very good at that AI is much better at? And of course, it's natural for us to devalue that. Oh, it's just predicting the next word. Oh, it's just clever. And, the analogy I like to give is, imagine that we were animals and humans come on the scene, but humans were primitive. As animals, we might have done the same thing. Oh, these humans look like they're getting smart, but can they do the things that we can do really well? And of course, there are examples where that's absolutely not the case. And this is one of my favorite examples of this, I don't know if it's a chimp, or I should have checked, I guess a chimp, which is shown for a second, the numbers from 1 to 9 in boxes, then the numbers disappear, and it has to just tap the screen in sequence from 1 to 9. And now you have to honestly think, how well would you be able to do this? So if this was the test, the animals, chimps would say, oh, humans are just, they don't have AGI. They just, they can't even do this, So I think that it's just an important perspective. You know, I think the danger is that maybe we're being blinded to some realities and dangers that we're entering, but because we're fixating on us as we're the pinnacle, we may actually miss really important stuff. Anyway, that's just a possibility. I also think, you know, we love to talk about hallucinations of AI, but we don't really talk about human hallucinations. So this is one of my favorite plots. If you've seen other talks I've given, you will know what this is. This is the probability of parole in the Israeli High Court justice system. And you can see the probability of parole varies from about 75% over there to 0. And obviously this, whatever's being plotted on the x-axis is really crucial for determining your probability of parole. And you probably can guess what the two dotted lines are. Can anyone guess what the x-axis is who hasn't seen this before? It's not the severity of the case. It's nothing that should be having an impact on judicial decision making. Yes, it's time. And the dotted lines are lunch and tea. Okay. So, you know, these are experienced high court judges with 20 years of experience, and yet they are essentially hallucinating why the person who's just before lunch should not get out of jail, right? This person is dangerous. And they're genuinely feeling it, but it's because of low blood sugar, right? You know, it's more of a statement about their internal blood sugar levels than the actual person sitting in front of them. So kind of scary, right? So now, of course, I don't want to suggest that this being critical about AGI is not a good thing, right? Because here was a recent study of 300, I believe, Americans, just ordinary Americans, and they were asked, to what extent do you think ChatGPT has phenomenological consciousness? And on a scale from 0 to 100, 0 means it has no consciousness, it's not aware, it doesn't experience anything. And 100, I think, would be essentially like human. And you can see there's a histogram, and you can see there was a bunch of people, roughly a third, who said, no, it's not conscious at all. And then everything in between, with the mean being around 25%. So having some level of consciousness. So it is important to push back on this perception that, you know, ChatGPT is actually conscious just because, you know, it's able to talk to you nicely. So, yeah, important to have critical debate as well. So, so this is the part inspired by the educator who was like, it's just predicting the next word. And so what I'd like to do is go through from the early days of large language models all the way to today and try and, you know, plot the advances and then get into this question a little bit more of, is it just predicting the next word? And, you know, in some level, that is true. So, oh, okay, there's a delay. So this is the past of ChatGPT. Down here below the surface, some of you may know it, some of you may not. GPT-2 and 3. How many people played with GPT-2? Okay, we got one. Great. GPT-3. Okay, more. And then, of course, we have the breakthrough moment with ChatGPT, GPT-4. Oh, the kind of omni models that can do images. Nano Banana, Gemini, the new Gemini model just released. And then you have these reasoning models at the top. So I'll go through this kind of cascade of dolphins, as it were. So GPT-2, if you want to play with it yourself, you can go to that link. So you type in something like a prompt. So I typed in, write me a poem about cats. And then you press tab, you wait for a couple of seconds, and then it predicts 1 or 2 words. And then you press tab again, and it gives you a couple of options, 2 or 3 options. And each time you have to select which of the 3 you want, and then you go to, and you build it up like that. So this was one trace that I got. I have no idea how to find the correct order for string. I'm really terrible at remembering. Can anyone help? That was its best attempt at writing a poem about cats. Or here's another one. Give me Python code to find the unique keys in a pandas data frame. Press tab, import pand as, and then you can see the three options there. P and P import. So basically gibberish, right? And if you do this exact prompt, give me Python code to find unique, you do it in GPT-5, you get beautifully congruent, Python commented with examples. That's in 6 years. It's really, really extraordinary how far we've come. So GPT-2 was a 1.5 million. I'm thinking that should be billion parameters. I don't think it's 1.5 million, but 1.5 billion parameters, 48 layers, trained on 40 gigabytes. Then the next iteration, GPT-3, was 100 times bigger, 175 billion parameters, 96 layers, and trained on 10 times as much data. Just for those of you who might not know what these neural networks look like, these are not exactly the same architecture, but the same idea. The idea is that you have multiple layers. So you can see these vertical strings of nodes. Each one of those would be called a layer. And so GPT-2 had effectively 48 of these, GPT-3 had 96. And that is partly what's driven the AI revolution, is this realization that the more layers you have, the more powerful the algorithm. We don't really understand why that is. We have some ideas, but the idea is that your data goes in at the left and then comes out at the end. In this case, it's about predicting what digit is a handwritten digit representing. So in this case, it was a 9. So you can see the number 9 lights up there. Anyway, these GPT models are different architecture, but the key idea is vaguely similar. And I'll just say, if there are any questions as we go, please just put up your hand and I'm happy to answer. So the way that these GPT models worked is you transform the input text into numbers by byte pair encoding. It doesn't matter. It's just a big lookup table. So for example, the might get mapped to the number 1, 2, 3, 4, and ing might get mapped to 5, 6, 7, 8. You learn those so that they cover your vocabulary effectively. And then you learn how to map those numbers into 768 dimensions. That's called an embedding. It's not too important, but it's an important part of the training. And then you get to the training of your model. And the training really was just to predict the next token. Not necessarily a whole word, could even just be a part of a word, okay? For less common words, you would predict parts. And so it would say, oh, if I give it the cat sat on the, it would try to predict mat, for example. And so mathematically, you were trying to minimize this function, which is the log of the probability of the next token, xt, given everything beforehand. So in this case, xt would have been the word mat, and x less than t would have been that string the cat sat on the. And that was it. You really were just trying to ask it to learn to predict the next word or the next token. So, the criticism, and this is, of course, where a lot of the criticism came from. Oh, it's just predicting the next word. It's amazing how far you can go with just learning to predict the next word. So the problems, of course, was that it wasn't actually trained to follow any instructions. It was just trained to predict, given a bunch of text, what should be the next token. And, in many ways, I think you could argue that it didn't understand. Because whatever you put in, it would just learn. It would just learn the next term. So, for example, you could give it meaningless strings that had some correlations in them, and it would learn to predict the next thing, even though the underlying strings are meaningless. So then, of course, we had the ChatGPT moment when suddenly everyone in the world heard about AI and large language models and so. So what was the key idea? What were the key ideas of ChatGPT? Well, the one is to use exactly the same training way that we discussed, but to get humans, instead of using all of the internet, get some humans to write down some instructions and answers. So it's a very like pure data set. So for example, you might say an input might be translate this sentence into French, I love science, and the output would be the appropriate French sentence. And you just have a bunch of these instructions and answers, and then you just do the same thing. You just get it to predict the next token, but you're getting it to predict on instructions. And of course, this is a very general paradigm. You can take your own data and then fine tune the model on your data. So for example, if you have medical transcription for South African doctors, you can get a bunch of data relevant to South African languages and to South African medical records and then train it on that. But again, there's still not any understanding because again, you're just getting it to predict the next token. Any questions? I'm going to build a fire break in to actually absorb the material. So the first step is just this step, you're just predicting the next token, but now you're just giving it this kind of pure data. You're saying this is the good stuff instead of just everything. You can imagine what's on the internet, right? Most of it is garbage, right? But there's a little bit of value in this garbage. It's like pigeons looking around through cigarette butts for little bits of food. But then you can say, okay, I've got this can of sardines where everything is perfect. And then you get your pigeons to eat the sardines. So this is like this. This is the good stuff. But of course, it's expensive because you need to get humans to go and produce this for your task. The big next step was to use reinforcement learning. So reinforcement learning is an old psychological technique. Yeah, as parents, you use it with your kids. You reward them when they do the right thing by your judgment, and you punish them if they do the wrong thing, right? So this was this was the thing that went from GPT-3 to ChatGPT that made the huge difference. So what you do is you get humans to rank multiple possible answers. Because the thing is that if I just jump back here, this probability, essentially you would have your most likely next token, and then you would have the second most likely, and then the third most likely. You have many examples. Cat sat on the mat, cat sat on the carpet, cat sat on my car. There would be a whole bunch of examples of decreasing probability. And so the idea is you could get a whole bunch of possibles, and then you could get humans to rank them based on which ones they liked. Okay? And it might be that the ones the human really liked were not the most likely ones based on the training data. And then the thing is, using this ranking data, you could train another little machine learning model that would predict in any situation which would be the ones that the humans like. Okay, so now you're trying to learn what humans like. You're not just trying to predict a word, you're trying to predict how they will respond to an entire sentence. Okay, and then you can use this model to change the probabilities. So the way I kind of think of it, this was like a finishing school for AI where you learn to be, act properly, and to make humans happy. So yeah, it really was, it's just reweighting the probabilities, but now it's specifically trying to make humans happy. So now it's not really just about predicting a single word, it's looking at strings of words and then comparing them, which is the most likely. So already we've moved on from predicting a single word. And of course, now you ask, well, which humans is it trying to make happy? Well, it's making happy the people who sat there laboriously ranking, all these possibilities, right? So of course, those humans are not perfect. They've got their biases, they have cultural differences. So again, what we start to see is that the leakage of of the human choices into the model. So that was ChatGPT, incredibly powerful, right? But not without problems. One of the problems with this reinforcement um, learning type of reinforcement learning from human feedback was that it was, as I'm sure you've seen, it was prone to telling you what it thought you wanted to hear, right? It's like, oh, you're so smart. Yes, you're right. 2 + 2 is 6. I'm sure, being a sycophant, basically. So so you can think, how would you get around that? Like if you had a little kid and you're training and all they said to you was, you're so smart, you're amazing, no matter what you did, that's not what a good parent does. A good parent is like, no, maybe sometimes I'm wrong. Maybe that does happen, apparently. And so now you want your kid to actually be, wait, I don't understand. You want them to fight with you a bit when appropriate, right? So one of ways is so-called chain of thought. You can ask the models not only to predict the final thing, but you can ask it to give you its intermediate workings. Okay. And then you can use exactly the same technique, this reinforcement learning with human feedback, but not on just the final answer, but the entire reasoning trace, the sequence of steps. Like, if you've got kids who've gone through school, they're told during mathematics, show your working. And even if you get the final answer wrong, if at least the first few steps were right, you'll get some marks. Exactly the same idea, right? You reward the process, not just the outcome. And this is sort of exactly like what we do at university. So there's this interesting question. If we do this at university and at school, and we believe it leads to humans who can think and who are intelligent and who understand, again, do we think that this would not lead to some level of understanding and thinking among AI? It's an interesting question. All right. So this idea and related ideas led to the so-called reasoning models, of which probably the first was O1, OpenAI's O1 model, followed by O3, then the DeepSeek reasoning R1 model, and then, of course, Gemini 2.5 and Claude. Now, maybe not most, but there are a lot of reasoning models. And if you think about it, now you're saying, show me your working, right? So there's multiple traces. So let's say option 1 has 5 steps. But remember that the AI can produce many options, right? So now you can have 10 different options. The first one has 5 steps. The second one has 7 steps. The third one has 3 steps. So now it's getting complicated, right? You got this kind of zoo of steps. And now you can think about it. Well, how do I select between these? I want to choose the optimal endpoint. So, you can do, for example, what you could do is you could just take 4 and work them all to the end. And then when you get to the end, you pick the one you like the most. You can try to be clever and you could say, oh no, at every step in each of these reasonings, we take the best one. This kind of greedy search. And you can try to be clever, right? You can take combinations. You can say, I'll give you a little bit of exploration time before I make my decision. And so, this is just a very active area of research of what's the best way, given all of these possibilities, what's the best way to select? And what's interesting is, I don't know about you, but this is sort of how I also work, right? If I'm doing a calculation, I might say, okay, I'll try and do it this way, and I'll do a bit of calculation, and then I'll think, is this actually leading? I'll try and decide, is this leading in the right place? And if it's not, then I'll maybe try something else, and I'll think about it. And So it's very similar in a way, human way of approaching it. And it works. It works really well. Of course, the really interesting question is, we are programming these things. Maybe there's a much better way to do it, that the AI would actually much rather do it in another way. But of course, it can't tell us yet how it would prefer to do it. Anyway, the key thing about this approach is that you get this thing called test time scaling, where if you allow the algorithm to think, you give it a question and then you let it think longer and look at all these options, you see a remarkable improvement. The longer you allow it to think, so on the x-axis is a kind of an amount of time that you allow it to think before it answers, the better the answers do. The other thing that's been really a driver of the improvement in the models recently is this notion of verifiable rewards. If you go back to this thing, some human said number 1 is the best, number 2 is the second best, the ranking is 1, 2, 3, 4. And now someone else might be like, no, I don't like this. I think number 3 sounds sounds good, right? And so it's very human dependent, these fluffy ones. You can imagine different people's opinions about poetry, very random, right? Very personal. But for things like science, you can verify easily. On a mathematics problem, you can actually check, rigorously check these things. Suddenly, the beauty of that is you don't need to pay a human to go and look and rank these. You can automate it by running a piece of code. And that's incredible because now you've got speed, you've got generality. So suddenly you can automate this process of the reinforcement learning, okay? So that's one of the reasons why we've seen amazing progress on the scientific side with these reasoning models recently, is because we figured out how to do this reinforcement learning in a way that's verifiable. So let me give you a demo. So I'm teaching nonlinear optimization honors course at the moment. And so I wanted a demo of a bunch of optimization algorithms. Go to ChatGPT 5 and say, make me a web page that demonstrates nonlinear optimization, right? All right, it's this HTML5 JavaScript thing. I can pick which function I want to look at in one shot. Essentially, no, it wasn't quite one shot. There was, the first one had a little bug. I said, no, there's a bug. It fixed it. Then it works fine. I can pick the starting position. I can click anywhere to change the starting position. I can choose the method. I can change the parameters. And then I can play. I can choose, for example, I'm going to say not gradient descent. I'm going to do Newton. And I can step. And Newton, of course, for quadratic function is great. Designed for quadratic functions. So it's going to be, I can change to atom, for example. And I can play. So in 5 minutes, I had this functioning demo. I don't know JavaScript. It would have taken me like, I don't know, 30 hours. Let's just thumbsuck to have done this which would have just been an absolute nightmare. So I think, okay, so I need to choose an example that's not gonna just have automatic solution. Okay, you see that sometimes it doesn't converge, which is exactly what you expect. But let's try Nesterov. That might have better behavior. Yeah, so just extraordinary. And if you look at instead the code, we're talking about, I don't know, about 1,000 lines of code just working out of the box. Now, it doesn't mean, of course, that there's no bugs, which is, of course, a subtlety, because the fact that something happens on the screen is very far from proving. But you could easily say, I want you to build unit tests, make sure that they're unit tests, integration tests. So, yeah, very interesting. One of the, so again, if we think about it, we're just trying to ask this question, is it just that they're predicting the next token, right? Is it just predicting the next word? And therefore, these systems are not intelligent. So here's another big recent kind of development is the idea of tool use. So that in the middle of its thinking, it might say, you know what, it would be super useful if I could stop running as a neural network and if I could go and write some Python code to actually do this. Or maybe I can call a web browser and do a web search. And how does it do that? Well, actually, it's very simple. In the vocabulary of the AI, you have all the English or Chinese, whatever language you've got, but now you just introduce some tokens that represent tool use. So essentially it says it presses the red button, and that is to call a Python. And it just learns, oh yeah, now would be a good time to call Python. Okay. And for example, R*2 agent just came out. It's still always the same idea, but what they've got is, what they're arguing is that it's thinking carefully before using coding tools, and then it reflects back on the code execution. So now it's thinking not about its own outputs, but thinking about the outputs of the tools that it's called. It verifies, and their whole point was when you use their algorithm, a 14 billion parameter, so the green curve is 14 billion, so it's very small. You can see it gets to 80% on the AMY 24 accuracy in about 500 reinforcement learning steps, compared to a 670 billion, DeepSeek R1 model, which itself was an amazing model, which took, over 8,000. So the DeepSeek model is, I can't do the calculations, 30 times bigger, 40 times bigger in number of parameters, and takes, oh gosh, 20 times longer to get, and it doesn't even get to this, the performance. So, I think we're still in this phase of figuring out how to train these models to use tools really efficiently. It's probably a lot of progress still to be done. But now it is just predicting the next word. The next word happens to be, hey, can I have a Python code executable, please? Right? So, yeah, very interesting. And of course, the tools could be essentially anything. It could be a web browser, as I said, search, but it could also be if it's embodied in a robot, it could be move, take an actual physical action. And so, someone like Jan LeCun is very much against the idea that large language models will lead to AGI. But I personally am not so convinced about that, because if this AI is running in a physical robot, the word large language model can be an action. Go and pick this thing up or punch that person, right? So, and then there will be a causal feedback, right? Okay, I punched him, he punched me, I don't have a leg anymore, So, I think there is a causal feedback loop that's potential. Then, of course, the other thing you can do is say, oh, well, what else have we learned about human brains? Well, one of the ones, Daniel Kahneman, thinking fast and slow, there are two modes in the brain. If I say 1 + 1 equals, you'll say 2 probably without thinking. But if I say, what's the integral of x² minus log of x, you'll have to do some sort of deep, slow thinking. So you could say, oh, well, let's try and just emulate that. And just recently, a couple of months ago, a paper came out with the so-called hierarchical reasoning model. They try to have a part of the neural network that's learning fast and a part that's updating slowly, so that you capture these two kind of timescales, and they got remarkable results. So I want to focus maybe on the Sudoku. So what you see there is that on these Sudoku extreme examples, on 1,000 training examples, O3 mini high, which is a great thinking model, small but very good, Claude 3.7 and DeepSeek R1, they all scored exactly 0. And this would be a traditional critique that these models are not, that we don't have AGI because they actually just they can't figure this stuff out, okay? And then this HRM, is getting 55%, for example, in Sudoku, or on this maze, it's getting 75%, where all the other models got 0. And the amazing thing about HRM is it's only 27 million parameters, whereas Claude 3.7, 8K context window, I don't know, actually, no, I don't know if they've released the number of parameters, but for sure, hundreds of billions of parameters. So, this is a really, really impressive step forward, right? So, yeah, the ability to learn from just 1,000 training samples. Because the other thing about AGI is typically we say, oh, humans learn from very few examples, right? You can teach somebody from just 1 or 2 times and they'll learn it. And if you have small kids, you'll know how not true that is with young kids about basic things, like actually, those skills build up really slowly often. It's only later that they appear to be very quick. And then just a couple of other examples. This is recent progress that are not yet at the kind of, wow, implemented in GPT-5 or 6, but probably will be implemented, is DeepConf. So this one not only is trying to use the things that we've talked about, but here is trying to actually aggregate probabilities of its internal confidence. And I think we do that as well, right? Well, as I said, you're doing a calculation. Have you ever done it? You start to calculate something and you go, feel something's wrong. Somewhere I went wrong. This just doesn't look right. So there's some internal measure of confidence that, of course, is learned. So they have done that. And what they found is quite remarkable performance. So this DeepConf here and here, because even with a very small model, like an 8 billion parameter model, they're getting essentially the same as DeepSeek R1, which again is a 600, I guess this would be the 600 billion parameter model. So this leveraging of signals that are there intelligently, I think will make them much smaller models and much more efficient. And here they were, I don't show, but the model ended up using a lot fewer tokens because essentially it starts looking and then goes, no, that's a dead end, and it's kind of develops a nose for what's valuable. So, have we hit AGI yet? I think obviously no, not really. We're in Stellenbosch, not in Cape Town, but I think we're very close. And so I'd like to give you some of the arguments why I think we're very close. So just recently, both DeepMind and OpenAI, their models got gold medals at the International Maths Olympiads. And this is extraordinary, I think. And I think, 6 years ago, we had GPT-2, write me a poem about cats. I have no idea how to find the correct order for a string. This was the cutting edge. Back then, if you had said, I think within 6 years, this approach is going to win a gold medal at the IMO. I mean, this is insane, right? To be honest. The idea that scaling this rubbish would get you to a gold medal in the IMO within 6 years, I think you would have had to been like clairvoyant to have backed that. Now this is the actual solution. So this is one of the problems. Let n denote the set of positive integers. A function f from natural to natural is said to be Bonza. If f of a divides b to the a minus f of b to the power f of a for all positive integers a and b, determine the smallest real constant c such that f of n is less than cn for all Bonza functions for all positive n. And so what follows is the actual output of Gemini, right? So this is the, I have no idea, oops, I have no idea how to find the correct order. So this is what it says. We want to determine the smallest real constant C, so it restates the problem. We will show that the smallest constant is C equals 4. So it already knows what the answer is, and now it starts to formulate it elegantly, right? Okay, part one, it lays it out. And, there were 6 problems. I think it got 5 out of 6 correct, which is the gold medal threshold. And ChatGPT did the same. So really extraordinary, And I think for me, why I argue that this is really a step towards AGIs. In 2024, Google did get a silver medal in the Math Olympiad, but they did it with AI that was trained only for mathematics problems. And the statement of the problem, which at the top, had to be converted into formal mathematical logical formulation for the model. So it couldn't take natural language as input. Here, 1 year later, there's no specialization to mathematics. It's just a Gemini language model can read the, can read the text and give you output. That for me is a massive step towards general AGI. So I'd like to tell us a little bit of a story. I woke up about a month ago with a brilliant idea. One of those ideas that as an academic you have a few times in your career. I was convinced that this was a really big deal, and I decided to chat with ChatGPT. So I put it on anonymous mode so that my brilliant idea wouldn't get stolen. And I said, I would like you to do a deep dive and evaluate this idea. So it thinks for 5 minutes. This is GPT Pro. And it comes back and says, yep, this is right. Because A, B, C, D, E. I can see we can follow the trace of this through the literature that no one's put these things together. I was like, great. And I was like, and am I right that if this is true, then this must also be true? And it thinks for a bit and goes, no, come. I thought you understood this. I mean, obviously that's wrong. Like, I'm really disappointed in you, but yeah. And it was extraordinary. I was really angry. But wow, first of all, it's like in 5 minutes it had essentially said, yeah, this is right, but you don't understand deeply. And then it gave me a whole bunch of reasons why I was wrong, and I couldn't follow it. It was involving maths and various other stuff that I didn't know. And I realized, wow, I'm back to being a student, right? I can't follow the reasoning here. I'm going to go and have to do a lot of work to understand. And maybe it's wrong. It's always possible. But that was really a bit of an epiphany, because I think, especially for those of us who are academics, I won't project onto other people, but I certainly very much define myself by being, I'm kind of smart, right? And I think I'm realizing I'm going to have to give up on that being a really integral part of my identity, because I think soon we'll all just be stupid compared to the AI, right? Like some of us will be a little less stupid than others, Now, that is a controversial take. So I'll just say that there are lots of people who don't believe that AI will be capable of doing really breakthrough science, but we're going to find out soon, within the next year, I think. So one of the key indicators of being able to do like valuable work long term is how long of a task can an AI do before it screws up. So here, this is Meta. They're a metrics company. They've plotted, you can see on the y-axis task time for humans that model completes with a 50% success rate. And what you see is exponential growth, and the doubling time is roughly 7 months. So currently, right now, we're roughly models can do what, with 50% accuracy, what a human would take 2 hours to do. 2 hours of solid work, it can do. This is average over software engineering, general reasoning, and cybersecurity. I think for mathematics software development, it's much better than this. But you know, we can put it not on a log plot, and then you see the pretty impressive growth rate. In fact, you can work out that in 6 years you would get, if this and it's a dangerous to extrapolate, okay, of course, but if this continues, in 6 years we'll get roughly 10 doublings, and that would mean we're moving from being able to be 50% success rate on tasks that take 2 hours to 50% on tasks that would take a human a year. You know, so that's yeah, that's extraordinary, I think, if that holds. So, you know, on this AGI question, we can try to argue about the technical details and performance metrics. But another thing we can do is look at smart people who have a lot of money and infer their view of it. And that's quite an interesting thing to do. Of course, it doesn't mean it's right, but it is interesting. And, you know, many of you will have seen this recent thing where Mark Zuckerberg went hunting for people that are working on the cutting edge of reasoning models. In this case of this guy who was offered $250 million a year to work for Meta. Sorry. I was sure I'd switched off all my alarms, but turns out I hadn't. So, you know, what on earth could it be? Why on earth would you pay $250 million a year to anybody, right? I think the logical superintelligence are really close, and that essentially the analogy is like, oops, did I? Okay. The analogy is like getting on the last chopper out of Vietnam. You know, this is Saigon, right? This is famous photo. You know, how much would you pay if you thought your life depended on it to get on that chopper? You might just give essentially this virtual device. It might be that is it possible that it's my no, I've got good battery. So I think there, and of course the fact that Mark Zuckerberg thinks that artificial superintelligence and AGI are just around the corner doesn't mean it's true, but it's an interesting indicative indicator that at least in Silicon Valley there really is a belief that we're just around the corner, and you've got to get on that chopper if you want to be competitive. And I think it makes sense, right? If you have the best AI, you have an exponential advantage over everybody else. Here's another amazing tidbit of signal. Demis Hassabis, who has led DeepMind since the beginning, have amazing results. DeepMind's had this incredible track record of delivering cutting edge stuff, and not the kind of person who makes bold claims. But just recently on an interview with 60 Minutes, he was talking about the rise of digital biology. He said, and it would blah, 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 it would revolutionize human health. And I think one day maybe we can cure all disease with the help of AI. And the interviewer says, the end of disease? And Demis says, I think that's within reach, maybe within the next decade or so. I don't see why not. Like when you speak to medical people, and I do that quite a lot, they look at you like you're insane, right? So he obviously has a lot of inside information. I think that's a really interesting signal. It's yeah. So there's another thing that I think is really kind of all related to this. So there's Rodney Brooks is a robotics professor at MIT. He's pretty negative about AI right now. He believes there's going to be a it's currently mostly hype, and there'll be a massive backlash. But he gives this example that in 1962, a distinguished Stanford professor predicted that computer programming would be obsolete by 1963, and that people would just converse in English with front-end neural networks. Okay. And he makes this point that every development in AI leads to this flourishing of hype. And of course, we did see that, these so-called AI winters. We went through 2 AI winters. First, good old-fashioned symbolic AI, and then neural networks. So in the experience there was people were like, oh, we're going to have amazing results next year. And then, of course, they were completely wrong. It was 40 years. They massively overestimated the performance of AI. But now we've got the reverse happening. So this was from 2016, a survey of AI experts where they sampled people and said, oh, how many years into the future do you think we will have human level machine intelligence? And you can see that the 50% estimate was about 40 years into the future. In other words, 2055. If you will look at this question now, I think the 50% estimate would probably be, I don't know, 5 to 10 years. So consistently in the last 10 years, we've seen that the experts are all overestimating, and we're hitting the targets much faster than the experts are predicting. And that's a classic thing of, I guess, of exponentials, right? We all tend to just do linear extrapolations, and exponentials will always beat those. So, for example, I think the one estimate for the probability that we would that an AI would win a gold medal in the International Maths Olympiad by 2025 was less than 8%. So over and over, we've seen recently how these projections. So from the same paper, what I like is they asked, when do you think we will have AI doing maths research? It was somewhere, I guess, about 40 years. So again, 2025. When will we have an AI researcher? Oh, that's going to be 2100. For some reason, the AI people thought that AI was harder than maths. Maybe that's a very human thing. But just a couple of weeks ago, there was this tweet. GPT-5 Pro can now prove interesting new mathematics. I took a convex optimization paper with a clean open problem and asked GPT-5 to work on it. It proved a better bound than what's in the paper, and I checked and it's correct. Now, people are arguing about, is this interesting maths? It's certainly not groundbreaking, but it's certainly novel. So again, I think we're starting to see this very human thing of moving the goalposts. Yeah, sure, it did that, but it can't do that. And when you get that, you move the goalposts repeatedly. But, you know, I think there's this undercurrent, which is very interesting, which is DeepMind is teaming up with at least one mathematician to work on really big unsolved problems. The Millennium Prize, $1 million to work on Navier-Stokes problem. And there's these indications that they may be close to a breakthrough. You know, will be really, really interesting, I think. And you know, I think again, so if all the experts are overestimating the time to a milestone, and Demis is saying curing disease within 10 years, that's an interesting signal. I just want to show an example of some code. I decided to test this. So what I said is I'm going to randomly grab one of the ideas that I've had in my list. I have a list of project ideas, probably 400 long. Just grabbed it, and all I did is I said to ChatGPT Pro, got this idea, I want to test it, build it. So it started writing code, and at every step, I didn't do anything other than say, next step, essentially like I would with a grad student. And well, first of all, just started writing code, and the code was essentially perfect. I just want to give you a sense of the amount of code. So this is a genetic algorithm with the idea of adding kind of, instead of randomly pairing parents together to cross over, you learn an attraction function on top, like humans do, right? And well, the code, we're talking actually thousand, I actually haven't calculated, but it's a lot. It produces, curves, it's testing, it's confidence intervals. I mean, it starts to, it's just a lot. Systematic tests. Yeah, it won't bore you. We're like halfway through it. There's like thousands of lines of code, all of which just work. Now, this is not groundbreaking. I gave the idea, it implemented it. But this is what I would say, I think a good master's student would probably take a year in the old days to have written this amount of code and checked. So, and I did this in an afternoon. So if you think a year of masters working full time, 6 hours, it's of order 100 to 1,000 times speed up. So, yeah, I think this really is, in terms of science, going to be a huge accelerant. Oops. So I realize I didn't animate this. So let me do this on the fly. So conclusions. Are we there yet? Do we have AGI? Probably not quite. But in some sense, I don't care. Because for those reasons that I said, I think it's not necessarily the right thing to focus on. And I think of this joke about the man who falls out of a 20-story building, and halfway down, someone leans out the window and says, "How's it going?" And he says, "So far, so good." I think this thing of like, oh, we haven't reached AGI is sort of missing the point about just how fast the acceleration is happening. And I think, maybe what matters to me more is a kind of notion of artificial economic intelligence, which is when are AI going to take jobs, real jobs? When are people salary not going to increase? When are new jobs not going to be available, etc.? I think in many ways, I think that's a socially important one. And I think, this paper just came out of Stanford showing AI for the first time having a significant and disproportionate impact on entry-level workers in the US. So it's really identifying AI as a driver of these job losses. So yeah, I think this is a really, really important question, and obviously touches on a lot of bigger questions. But yeah, I'll stop there. Thank you so much.
Thank you very much, Bruce. You definitely gave us lots to think about. Are there questions for Bruce? Sure, please.
Thank you very much. It's a very, very interesting talk. I often struggle ChatGPT to give me many lines. Do you do it by asking it to continue over and over, or is there some other secret?
I think the secret is the paying for the pro version. I don't know if you.
I have, yeah.
The pro version. Yeah. That's interesting.
Sometimes it just stops.
Might have the plus version.
Oh yeah.
Oh, okay.
So I'll be honest. I was saying to Francesco earlier, the pro version is $200 a month, right? I bought it.
No, I don't have it. No,
I bought it for 1 month because this is supposed to be my area. So I thought, okay, I can't go making around claims if I haven't at least tried it for one. So I paid for 1 month, fully expecting that I was not gonna be worth it, and I've never even contemplated going back. So, yeah, I think there's a huge jump from pro to from plus to pro. Like when you really need the power, it's really impressive. Yeah. Like, for example, if you have DNA analysis blood tests, and you feel comfortable, you just upload and say, give me a detailed analysis against the literature with my genetic mutations. one thing I was doing recently is getting it to do financial portfolio allocation for me. Yeah, but and yeah, in terms of science, it's really, really impressive.
One more question over there. Thank you.
Thanks, Bruce. Yeah, really interesting. One of the, you talk about the progression and that, you know, there's some exciting things that are going to be incorporated or likely to be incorporated that will drive future progress. But that sits on some core assumptions. So some of these simulated reasoning models, there was some work out of Anthropic a couple of months ago that showed the reasoning traces that are output actually have nothing to do with the internals of the model. And there's no architectural reason why what it tells you its thinking steps are actually what's there, and something like 40% of the time it's not even there. So my question is, the current architecture that is being used for test time compute, do you think scaling that is enough? Or do you think there needs to be some fundamental architectural change where the chain of thought reasoning is much more aligned to what's actually happening under the hood to guarantee this kind of continued exponential curve of progress?
Yeah, the bottom line is, of course, I don't know. Maybe I'll just make a comment that what was interesting about the hierarchical reasoning model, right? This one that is that it's back to an RNN, so a recurrent neural network, right? So it's not a transformer-based model. It's a recurrent model with 2 loops. So, you know, I mean, the weird thing is, like, in physics, as a physicist, the idea that essentially linear models could give you this kind of breakthrough was just unfathomable, right? We used to make fun of economists for using linear models, right? As physicists, you know, progress in physics is so hard, right? You'll have a breakthrough, everyone will get excited, like string theory, second string revolution. It's going to change the world. We're going to have and then like desert, right? A complete desert for 40 years. Although string theorists might not characterize it like that. So this, in fact, the deep learning progress, just unparalleled, I think, in the history of science. It's just like, just pure exponential for, you know, now 14, 15 years. It's just extraordinary. I don't think we really understand why. I mean, there's indications. So I think but if you look at that, it's actually been a series of transitions. It's like you're on a boat, the boat slows down, but just as it's slowing down, another boat happens to be passing, you jump onto that one, right? So RNNs to CNNs to RNNs to transformers, and now maybe back to RNNs. I think, you know, a lot of the goal is to, again, have better scaling than transformers with as a function of size, etc. And I think there's lots of exciting things. The one thing as well, which is kind of interesting about this, is that it's not pre-trained, right? There's no pre-trained model here. You give it 1,000 examples and it trains. So in some sense, you could imagine hooking this up to give you continual learning. And I think that interplay is a current limitation. We don't have good ways to react and learn in real time. So yeah, I don't know. Hey, I think there's so many people throwing paint at the wall to see what sticks, is that something will work. And then, of course, you know, then they'll say, oh, yeah, this is just a large language model. You know, it's like, yeah. A bit like string theorists. Remember string theorists saying, string theory is whatever the string theorists who are working on this evolved the field into, even if it doesn't have any strings. You know, oh, it's conformal field theory, you know. Anyway, so I think it'll be a little bit like that again. So, yeah, I'm not sure. You're the only one who had played with GPT-2 at the time. Yeah.
You can run it in Excel now. This is really good for anyone that wants to understand the internals.
Oh, amazing.
Fascinating, because you can actually go and probe and see at every step what it's doing. It's a really intuitive way of understanding what's happening under the hood.
Oh, beautiful.
In Excel.
Yeah, that's a sign of how things have moved.
Any other questions or interesting comments? Over there, please.
Yeah, thank you for your talk. Quite mind-boggling what the future holds. If my question is that if all of this is all of these improvements with AI is happening with classical computing, can we imagine when this is on a quantum computing level? I just want to get your thoughts on that. Thank you.
I'm not sure my opinion's worth anything, to be honest, on quantum computing, because it's not my field. Francesco, you're probably a better place to talk about this. My understanding, and Francesco, please correct me, is that quantum computing currently is very limited number of problems that we can actually tackle, but that could change at any point. I sort of personally hope that it doesn't work, because I mean things are bad enough as it is, you know. Now we have a super intelligent quantum computing. But Francesco,
It will eventually work. But at the moment, the bottleneck is to input classical data into a quantum computer. That's very, very slow.
Yeah.
So that's why they won't be able to do billion parameters and learn large data set, because it's very slow to input classical data into a quantum state.
right.
But you know, things are improving there day by day as well.
Yeah. So, I mean, who knows? And of course, what we're seeing, and I actually didn't mention it because I mean, I went over time as it was. But for example, the obvious thing, and which was behind Ray Kurzweil, for example, always predicted the singularity, that we would hit AI with essentially infinite intelligence in a finite amount of time. And the idea is simple. If the AI designs the next generation of AI, and the AI is getting smarter, we might get super exponential improvement. Now, of course, that's an assumption that the difficulty to get to the next generation is constant, right? It could be that getting to the next generation gets also exponentially harder, in which case you wouldn't get the singularity. But we're already starting to see the situation where AI is generating the new next generation. And so at that point, the AI gets really smart. It may solve these problems around quantum computing. And I think that wouldn't be an unreasonable expectation. Yeah. So, I mean, yeah.
Do we have, here, there's another question here, and then we can look at questions from our online audience. Please.
Hello, how are you?
Good, thanks.
I would like to ask a question with regards to, there was a recent study by MIT that says that despite a lot of economic investments, 95% of businesses that implemented an AI program, a generative AI program, did not show zero returns. What are your thoughts on that?
I didn't look into it in detail. I did see a rebuttal. So I think agentic workflows are very immature. So, and a lot of people are making an analogy, and I think it was actually said here. Yeah, this one on the left. Meta is paying a 24-year-old AI researcher $250 million, echoing the dot-com bubble. So this idea that, oh, people are throwing money at it and it's not worth it, it's all gonna be worth nothing. I think the better way to think about it, which is similar, is it's just like lottery tickets. There's a belief that there is a huge prize to be won and nobody knows which is the right ticket. So everyone's just like, well, I want to play. Yeah, I'm willing to put my money into the hat to play, knowing that there's a 95% or 99% chance that you're going to lose everything, right? But it's worth it, because if you hit it, like if someone said, okay, there's a ticket, it's going to cost 50 Rand to buy a ticket, but you have a 1% chance of winning R1 million. Would you buy tickets? Yeah, you should absolutely buy tickets, because on average, you would expect to make a lot of money. Average in the sense of you lived in a multiverse with 1 million repeated things, which of course we don't. But I think that's what's going on. So I think the point is for companies, if you don't get on board with this and AI keeps going the way it is, you are dead in the water. You're just shooting yourself. So you have to learn. So what those statements about, oh, 95% don't give thing is, they're forgetting that the staff and people are learning a lot and adapting and doing the cultural shift away, right? So it is absolutely true that agentic workflows are quite poor at the moment. And I mean, you can sort of already see it. Let me just try and just pull up that one plot. Ugh. Is it this one? Yeah, this one. You know, if your agentic workflow requires something that would currently take more than a few hours for a human to do, you have a very low probability that your agentic workflow will handle it robustly, right? But, you know, this is just one of those examples. Just wait a bit. You know, it's like the guy falling out the window. You know, you're saying he didn't hit the ground. It was just wait a bit. It's coming. It's definitely coming. So, yeah. And again, I think, are the humans infallible? Like, I had some recent experience with humans, which just really depressed me. Unbelievable. I was like, the sooner these people are replaced by AI, even if it's not perfect, the better, right? I mean, I don't, you know, I probably shouldn't say, but if you've been to, you know, Home Affairs or passport renewal, you know, so yeah, I think it's just temporary. But it's also possible that this, you know, we always learn in science, extrapolation is extremely dangerous. So it's all contingent on, you know, the music not stopping. And there's always a chance that, like in physics, you know, like string theory, they had this incredible progress and then it just stopped. You know, it was like, oh, well, we don't know what to do. It's possible that that will happen again, but I don't think so. I think that would be really surprising, but, you know, we have to be open to surprises. Yeah.
Donovan, do you have any surprising questions from the online audience?
We've got two. The one is on mechanistic interpretability. Your thoughts, please.
Yeah, so I think this is a bit to the point that Alex was making, is that what the AI says it's doing and what it actually does don't necessarily have much to do with each other. I mean, I didn't really touch on it. I touched on the job losses at the end, but I mean, when the AI has an IQ of 170 or 190 or 200 or 500, whatever that means, how on earth do we control it? Probably it's very hard, right? So the desire to be able to interpret it is very natural and really important, right? I'm a little bit pessimistic about the possibility that we will be able to really interpret these things, right? I mean, there's that old joke about, if the human brain was simple enough for us to understand, we'd be too stupid to understand it, right? And it's sort of maybe not too dissimilar with these models, right? We can now understand GPT. And in fact, a lot of these papers on interpretability are done on really small models, right? GPT-2, GPT-3, small models, because they are handleable. We just don't have the technology. And the problem is there's very little economic incentive to really take this seriously. So if you could make billions of dollars by understanding the AI, people would be investing billions of dollars to understand AI, but they're not, right?
Cool. And the last one from Tuto Mosuang. Does AGI mean that one may get an intended code to calculate one's problems without actually understanding the steps of the code? So this ties together with.
Absolutely. Yeah. No, I mean, and this is the danger, right? Is that we just blindly trust it. And, you know, in the old days, you would ask for a piece of code and it wouldn't work. It just wouldn't compile, or it just give you an error message, and then you'd have to go through this loop of trying to get it to run. This genetic algorithm code that I wrote, it just runs, right? But I didn't check 1,000 lines of code. So there's it's very easy to conflate the fact that it runs without error with like really, really bad, right? So I think as a user of these systems, we actually have to, the scientific method becomes mission critical. We have to have discipline and say, like we would with students, grad students, check this. I want to see this test. I want to see this thing. The fact that it seems so brilliant is very easy to be, I think, to trust them when we shouldn't. So I think this is critical. But again, the fact that these things are verifiable means that, again, I think within a year or two, mistakes are going to be very few. There might be mistake in understanding what you ask for. But again, I had an incredible example. I was trying to combine data across 3 different data frames. And I was going mad trying to write this code for myself. I couldn't get it straight in my own head. And after about an hour, I was like, okay, I'm going to just ask ChatGPT. And I wrote this prompt and I looked at this prompt and I was like, I don't even know what I'm asking here. This is just gibberish. No human would be able to make sense of what I wrote. I pressed go, it wrote some code. And I was like, well, I'm going to run it. And then it figured out what I was trying to say. And it had written this thing and it was exactly right. I could not believe it, right? So for me, I mean, that's maybe just a statement about the limitations of my brain, but I was really impressed. Right? That was able to like put together the gibberish, the little bits of signal in my prompt and figure it out. So anecdote is not data, but yeah, it was a fun anecdote for me.
Bruce, all good things come to an end.
So time for wine. Thank you so much. Thank
this
you.
Is our famous bizarre comment.
Oh, fantastic.
Give it to you before.
Oh, no, that's perfect. Thank you.
I think Donovan is taking the
awesome.
photo. Thank you very much. And if the AGI didn't compromise our plans, there should be some drinks and snacks outside. So please join us outside. And thank you to the online audience as well. The AGI won't provide drinks online.